Welcome to video clip 5.2, in which we discuss data and data flow. Regarding the bpmn, we covered a number of notation categories already, and today in this video we look at data objects and also at associations of data objects to activities. To motivate data in business processes, well, first motivation is very easy. All business processes that we look at some point change data, access data, create data. We've seen in the previous video that processes use input and provide output, provide results to customer process. So all business processes are involved in the handling of data. However, traditionally, the focus on business process modeling is rather on activities and on the control flow and the flow of execution of activities, and not so much looking at data. And we see this in the reseller example where we have order first, the event, the order is received, then check order, reject order, approve order, prepare parcel and send parcel. If we look at this example, on the one hand, we see quite nicely that we, of course, have the business process model with just the activities, the gateway, and event. We don't have data objects. But if we look carefully at the labels here, we see that we have an order here, we have check order, we have reject order, another appearance of the term order, and here we have appearance of the term parcel, and again the parcel, and here again the parcel, and here the order. So this apparently we implicitly talk about data objects even when we don't explicitly represent the data objects. So if you look at process models that do not have data as explicitly, then still you see in the labels that there's a reference to data almost always. All right, so looking at the execution of business processes, during the execution, data is created, manipulated, and used. Data serves as input, is created as output, and also drives decisions. So many decisions are based on data. We've seen that the XOR split decision that selects one of the outgoing edges is driven by data, and data therefore also needs to be represented in the process. Representing data objects in process models help bridging the gap between business and IT. Also that is useful because when you have a database and you want to design a business process on top of this database or several databases, you can use the data objects to then really link the process to the data stored in this database, for instance. What will be covered in this week is the modeling of data objects, dependencies between data objects, possible states of data objects during process execution, and also the relationships between data and process activities. When you look at the modeling of data in bpmn, we'll see that there is first of all the abstract syntax, so the concept, and the concept is the data object. Concept is represented here on the left-hand side by text. So the data object is the abstract syntax. Data objects are described as items, physical or information items. So you use data objects to present or to represent information items, like data that is processed by the business process. But it can also be physical items like orders or shipments, like parcels being sent, and things like this. So, and here we have this symbol we use as a concrete syntax, as a notation. In bpmn, we use this for the data object. Data objects can have states, so very similar to objects in the object-oriented world. Data objects can have states, and the states of data objects can, of course, change when the values of the data objects change. And we can write, if we write or we can represent the state of a data object by writing this underneath in a bit smaller letters as we have shown here. bpmn is not very good at representing data structures or structured data. The only data structure that we have is the list. And the list is represented by this multiple instances symbol that we use for multiple instances activities already. So when you encounter the data object with these three lines in the center bottom of the data object, we see a list of orders in this case, a list of data object of the kind specified by the label of the data object. We can also represent data storage. So this is used to represent databases, but can also be used to represent other types of information systems that store data or that have a relationship to data. And this is represented by this typical database symbol. Processes also work on external or use data that are provided by external sources or by other processes. We've seen this in video clip 5.1 in quite some detail. And this data is then used data input. Data input of a process is data produced by another process and taken, read by one business process. And the symbol for the data input is this one, and the symbol for the data output is the filled one. And of course, data output is then the output produced by one process, and that is available after the termination of the process to be then produced or to be then read and consumed by the customer process. Okay, to go into a little bit more detail regarding data input and data output. This data input and data output represent input and output of data to the entire process or to sub-processes. We can also use this symbol to indicate input and output of data to sub-processes. If applied to a business process, data object existed before the start of the process, was created by another process. And data object exists still after the termination of the process. So this is also relates to persistency. We come back to at the point of persistency a bit later. All right, so we have a task here in this simple example, and the very simple process, almost the simplest process you can think of, that takes data input. This data input was present already before the process has started and creates data output, and the data output survives the termination of this process. All right, when we want to represent data objects, we can use associations like we've done here. I should, because it appears here the first time, I can say a few words on the association between the data object and the activity that holds both to data input, output, as well as to normal, to other data objects. And that is that the direction represented here, represented by the edge, shows the flow of information. So the task, in this case, the task reads the data object. So the task, let's show it like this. The task reads the data object, and in this case, the task writes the data object. So reading and writing is represented by the arrow, by the orientation of the arrow. This is shown by the following example, maybe even a bit nicer. So we have here a sequential process starting with check order. Check order creates an object called order. So thereby, by this association, it is shown that when a check order completes, it creates an object, the order object. And the order object is then read and written by a proof order. Here you see this association edge with a double orientation. We see that the proof order activity reads the order, modifies the order, and can write the order back. Then the prepare parcel activity is executed, and it reads, here we see the read edge, reads the order and produces a parcel. So I use the information provided by the order to produce a parcel, and that's also represented by this write edge. And finally, send parcel reads the parcel, or takes the parcel. Also physical activities can be associated here. And finally, the parcel is sent, so the end event of that process occurs. So dashed edges indicate the reading and writing of data objects by activities. And I'd like to expand a little bit on the term data object, and data object is not really very precise in terms of the object orientation, of the area of object orientation, where you typically have a class as a container for objects of the same kind. And here, when we talk about data object, it's not an individual object, but we are on the type level. Business processes are on the type level, specify the structure of many process instances. And in the same line, a data object in BPMN represents the structure or the occurrence of many different data instances, data object instances, so to speak. So it is called data object, but it is still on the type level. We should bear that in mind. Okay, so we announced that we talk also about data flow. We've been doing that in the previous example somehow implicitly. Data flow between activities related by sequence flow can be expressed in a condensed form. And before that, we look at now the right-hand side here of that, where prepare parcel created a parcel data object. The parcel data object was then read by send parcel, and we can use this syntactic sugar. So we save one edge, and we can just attach or associate the parcel with the sequence flow, and thereby we indicate that the parcel is that the object is created by prepare parcel and is read by send parcel. So that's a simplification of the model without losing any precision here. We should also say that the structure of data object is not represented in BPMN. So the structure of data objects, however, can be modeled in modeling notations that are more useful for doing this, and that is, for instance, UML class diagram or also entity relationship diagrams. And in typical projects, we have, it's the case that the data objects that we see in the process models are then refined and detailed in UML class diagrams. Like in this example, we can have let's say, a UML class diagram for order or for parcel, or could also be an ER model. All right, we talk about concurrent access. So in a process model, we've seen that we can model concurrency. We have the end split, the parallel split. And we, of course, could, I will choose, let's say, the black ink color, the pen. And I like to show you the problems that might occur here in a simple example. So we have a process. I will not label the activities. It's important that we have concurrency, that we have an activity here, and that we have an activity here. The concurrency is then synchronized, and then we might have another activity, and then we have the end event. And we can have a data object here. So data object, let's call it D, and we can specify, well, the data object is read here, but also written, read here, but also written here. And the data object can be written, let's put it like this, so that we don't need to discuss creation of the data object in the first place. So the first activity, now, well, let's call it activity A, creates the data object D. On termination, data object D is there. Then we have activities B and C. These two activities are executed concurrently. And then we have the data object D that is read, or that is read and written by both B and C. And when we have concurrent access, concurrent read and write access to data objects, we know also from the area of databases that we can have situations like a lost update situation, where two activities read the original value of the data object and write afterwards, the modified. And of course, one modification is then lost, and that refers to the lost update problem. So assume that B adds, let's illustrate this a little bit. So B adds plus 10. I just do that in a very informal way. C does plus 20. And the initial value of D is 100. Okay. So what happens is that it can happen due to the concurrent access that B and C are both reading the 100. That then C is writing the new value, 100 plus 20 is 120, so D has the value of 120. And only then B writes the modified value, so its modified value, it read 100, added 10, makes it 110. So that after B and C have been executed, D can have the value of 110 only, which is obviously false, since both activities should be executed, and we would expect that the value 30 had been added to the value of D. And that is called the lost update problem. It's one of the problem. And this is solved by, for instance, by locking algorithms in databases, or by the transaction processing that databases provides. This problem can be solved. In relationship or related to bpmn, I discussed this with you because bpmn does not provide any means to express transactional properties regarding here. There is something called transactional spheres. We leave that out because, in my opinion, these transactional aspects are not very well specified. But with the normal construct that we have been looking at so far, we cannot provide means to express transactional properties. Managing concurrent access to data needs to be done by IT systems, for instance, database systems. And if we had B and C accessing data object D in a relational database with transactional properties, then we would not run into that problem because the database system would solve that. That's the point I wanted to make here, that on the modeling level, we do not make any assumptions about the access that, and thereby this lost update problem could occur. That is then left to implementations to make sure that these problems like these cannot occur. All right, finally in this video I want to discuss data object states. We already said that data objects can also have states. And data objects can have a state that is a representation of the current value. And state transitions are triggered by activities that write data objects. So an activity can read a data object in one state, make modifications, and write the same data object in a new state. We have an example here, and that is the check order activity creates an order in the state checked. The approve order activity then reads an order in state checked and writes an order in the state approved. So effectively there is a state change of the order data object from checked to approved. And we then have the same or similar for prepare parcel, where the parcel data object is created here in the state prepared, and the send parcel activity then puts or changes the state of the parcel data object to send. So here also we have a state change of the data object parcel. And we could also use the shorthand writing that we've been introducing before. We can also use that in connection with the states. We also can use several data objects. We have seen that in the previous example, but here we see it a bit more clear. We can also have several data objects, and one activity can modify several, can read and or modify several data objects. Here we have an example, again, where the order is received, the order is checked, it might be rejected, or it might be approved. In case it is approved, the order is approved. We first prepare the parcel, then we have the parcel in state prepared. We can send the parcel, and sending the parcel also required the customer data, the verified customer data, that is data input to this process. And it creates a number of things, transportation document or transport document, a delivery note, and also the parcel sent afterwards. So that's an example of a business process where we have several data objects represented. This brings us to the end of video clip 5.2, in which we discuss data and data flow. We've seen that data drives the execution of business processes. Data objects in BPMN can be used to present items, physical items or information items. Data objects have states, and also during the execution of a business process, data objects can change their state. Data objects can be input and output of activities. In this case, they are local. They are local to a business process, but they can also be input-output of the whole process. And that is called data input and data output to the process. And then they existed in the case of data input. They existed before the process started. And in terms of data output, the data object exists, will exist even after the process is terminated, so that the next process in line can use the result produced by this business process.